Hey all, today we are going to start with the computer vision. This playlist will continue various video, not of too much length. And for today, it is an introductory lesson about the computer vision, so it would not include any coding. So you all can simply sit and listen and note down the points. I will also share the PPT and the lectures along with the YouTube channel in my YouTube channel only. And from the next session we will go through coding. So from next session you all can be ready with your any notebook like Google Colab or Jupyter, simply the Visual Basic also, which you feel comfortable. But from my side I will be proceeding with the Colab, and if you all want other going through the other ID, then you can inform. Yeah, so let's proceed. So basically, what is computer vision? We all are familiar with the term AI, artificial intelligence. Artificial intelligence, mainly in a layman term, we can say that we want our machine or we want to make the machine so as he or she or it can think as ours, like we, how we talk, we understand each other, how we analyze, we predict, like means a kind of analysis similar to men. So basically AI, we have three types of domain. One is the machine learning that basically deals with data, we numerical data, like we predict, we derive insights from a data. Like for example, there we have a data of people staying in Bangalore or people staying in other part of India or anywhere, and their income status or the house they want. So by learning from the data, we can predict that if a person lies in this state and this much income he had, so he should buy this home, or like that, like kind of prediction with the real numbers. And when it is a one kind of human activity, like we analyze as a human being, we analyze a situation whether to buy, whether not to buy, we calculate sometimes. So that part of AI deals with the machine learning. And when it comes to understanding each other, understanding the language of each other, reading from a text, or giving answer to a text, writing a letter, anything, that will come in a form of NLP, a domain of AI known as NLP. NLP stands for Natural Language Processing. There means, for an example, we can see that some in children, if we remember, we were given one or two paragraph and we were asked to write a summary of it. So by using our analytical skills, by knowing our vocabulary and all, we frame that a small thing. Or giving, we write a letter to our friend in small, like knowing where they have spent their holiday, what they have done in their vacation. So like that, so it is basically a communication and understanding each other through text. Even the speech recognition also comes in NLP only. There are many models now, like text to speech to text, or sometimes also you all may heard of language processing, large language model, that mainly this chat GPT and all. So basically that is not total NLP, but it is a little upper form of NLP, large language models. And in basically in this playlist we will be discussing about computer vision. Computer vision, mainly we want the human to analyze the video or analyze the image or try to get the insights from image as a man, as a machine human being. So let's proceed with this one, computer vision. So what is the computer vision? How it deals in our real means daily life? How we should incalculate it in? How we should make an application? So we will be discussing it in further lectures. But for now, let's have an introductory section. So what is computer vision? Speaking frankly, that it is simply a machine which could interpret and understand the visual information from the world as we listen and we see and we analyze. So basically, computer vision is used for object detection, image classification, semantic segmentation, 3D construction, facial recognition, all these and many higher tasks. So let us discuss some of the tasks and some of the things which computer vision help us in, and then we will forward be going that before pro computer vision what we were applying to get all these and how it was. So let's move further. First, for the object detection. Okay, so what is object detection? We can see a image here. There means there are many bounding boxes. They say that whether it is a car. Here also means basically here traffic light we can see a person, we can see bicycle, car. So basically what is object detection? Imagine that we have a photograph like this of a busy street. There are cars, people, buildings. So object detection is like giving a computer the ability so that they look at the photograph and not only recognize these different items, that whether there is car, whether there is person, whether there is building, but also points out exactly where each one is. Means give it is a kind of mixture of localization as well as class, means we cannot say fully classification, but yeah, kind of classification. So where are its application? We can see its application in the form of smartphones, in self-driving cars, in security system, in shopping apps. So in case of a smartphone, how we get like our phone camera sometimes detect faces to focus better, apply filters like we are using. There are many apps like B612 and many AI apps in Google Pixel phone. Like what we do that basically and there they uses a kind of object detection method to detect where the person's face is so that they can apply the further image processing method only on the face, not anywhere else. And then we come across the self-driving cars. We all know that Tesla, we all know much aware of Tesla, and now other company of India, Sweat Robots, that is also really a small level. They are in a small level or is initial stage, but they are also doing a great job with converting a Bolero on Indian street as a autonomous vehicle. So basically, while driving a vehicle, we can see that there are many poles and footpaths, buildings. So, how can a car know that whether it is a building, whether it is a stoppage, whether it is stone, we should not go? So, the algorithm teaches the machine that these are the objects which are detected. We should not go there or we should move thereby. Like if there is a traffic light, so if they detect a traffic light, the vehicle detect a traffic light, then the algorithm simply checks the three colors, which position it is. If it is a red, then the vehicle stops thereby only. So it is mainly used in self-driving cars. Another is known as the security system. If a like if in a building they have a building or a bank, they are mainly the security much concerned. They have a room special there where the bank employees only can go. So there they can deploy that. That if any other objects can be seen entering the room or any other person, the alarm triggers. In shopping all app also you can find them to identify the pictures. Like Mintra, I think so uses this. If you can see that we click the pictures and try to search them online. Mintra or what I mean simply our web search also works like that only. Yeah, so let's move at the other thing which we will be laying image classification, what it is and how means what is known as the image classification. So yeah, what is the image classification? So image classification is mainly a technology in computer vision that enables computer to look at the image and decide what kind of object or scene it shows. In a simpler terms, it is just asking a computer to look at the picture and tell you what it sees. So basically, you all will be confused with the classification on object that both we are drawing the bounding box and mm, looking at the images or looking at the thing which is there in images simply bounding, but there is a vast difference. If you can see That means I will go through the applications and then I will try to understand, try to say that why they are different and how the use cases can be different with the image classification and the object detection. While going through these of the application, you might get some of the idea about their differences, but yeah, we will go in detail about that. Then first understand the application of image classification, and that then we will go to the differences. So one of the application is photo management. Basically, our smartphone automatically short out photos. Like if we have means if in my phone only, in my photo, my sister photo, my brother photo, the smartphone by itself only make three albums where all our photos are there. So basically it is a kind of classification because it is looking at all the images in my gallery and assigning a label to it. You can say by giving us, I will give one example. So, like if you go to Nainital, if you go to Rajasthan, the places are really different. So basically, our phone can separate them with a label that it is a Nainital, is a means Rajasthan. Then on social media also you get a classification when you try to when you upload a photo, we can tag the person. So our the algorithm on the social media platform also tells that these persons can be here, so we tag them. Then in medical imaging also we can be used for classifying the fractures or tumors in human body. And then same as the shopping apps. So yeah, moving forward there will be a table classifying the difference between, telling the difference between the object detection and the image classifications. So, what is the basic difference between the object detection and image classification? So, object detection is mainly used to identify and locate multiple objects within an image. Like, if you are given a basket of fruit, it will identify all the fruits and it will say, yeah, this thing is there. Whereas in image classification, it determine what is in an image. Basically, how I can say means I will move forward and I will give you with an example. In object detection, it is identifies and locate multiple objects within the image, providing labels and positions for each. Focuses on the entire image and assigns one label. Okay. More complex because it needs to handle multiple objects and their location. And here it is generally simple because it only needs to assign one label. Here multiple class label and bounding boxes like car, person, bicycle, each with a box. Here a single class label cat will also work. So, for example, if you are given a basket, okay, and image of a basket which has many fruits, and if an object detection algorithm runs on it, so what is that? Where in that image where it identifies that there is some object, it make a bounding box around like apple, mango, grapes, banana, and it will make a bounding box and will try to give a confidence matrix. Whereas this image classification, what it happens, we tell the algorithm that we need to classify the images in this three categories. So how we will classify it? So what it will do, like if we only want banana and apple, so it will only classify among all the images that what is banana and what is apple. Means basically we can say that an object detection, we have to detect all the objects in an image, and its classification, it depends on us which image we want to classify and which image we don't want to classify like this. Then comes the other thing which we can do with computer vision. It is a semantic segmentation. So semantic segmentation is a computer vision task that involves dividing an image into regions and labeling each region with a category. In simple terms, it is coloring a picture. Like here we can say that there are we can see that there are car, man, moving, trees, buildings. So with this image we can see that the tree has given green color, the cars have given blue colors, and the man or persons are given the kind of maroon, and the buildings are brown. So basically, semantic segmentation is grouping the similar type of objects with a color. Like here, if we want, me say for simple, it is not visual to us, but if we want a large program that simply that how much percentage of area is covered by tree in a huge region and we are given video, then we can simply get this segmentation point and calculate the area along with this. Means basically in this, means in semantic segmentation, it colors each of the pixel of the image. Like for car, it will color the blue to every each and every pixel of the car. So by this we can get mating and other. So let's move to the other thing. This is the 3D construction. It is basically making a 3D sculpture or model from a 1D or 2D images. So basically, why we will get the angle or alignment or the diagonal relationship and get the formation of the new images. Oh, sorry, I have moved here. Basically, as a earlier slide, we saw that semantic segmentation. There is also a instance segmentation that I will give a detailed description. In these also, I will give a detailed description along with the code and all in the upcoming videos, which I will be posting for each of the method. So let's go and see the application of this 3D construction. Then you will understand better that where it is used. Applications are in medical imaging, gesture recognition, cultural heritage preservation, entertainment, and gaming. Like in medical imaging, if we get a picture also of some X-ray, MRI, CT scan, then we can convert by changing the angle into a 3D image. And then in cultural heritage preservation, like we have got a something old building photo, then we can make a 3D construction of it and see that what our ancient rulers and all were there, what sculptures were there, what they have made. And like same in entertainment and gaming, like virtual reality, we can get the 3D images and all, and it will really make the game more amazing. Yeah. So now let's move to image processing. We all have heard that image processing, we are processing the image, we are making it bright, we are changing the order, we are adding something. So how it is different from the computer vision? So image processing is just a subset of signal processing. Means we can change the enhancement, we can reconstruct, we can transform, we can compress, but we can't carry out a huge task. Means if we I means it is not similar, but yeah, you can think it as a data analysis and data scientist. Like data analysis is a kind of image processing. Like we already have a data, we can get the insights from it, we can transform, we can carry out some mathematical operation, but we cannot means predict or do anything larger than our analysis or construct anything. And so like moving forward, we will look at each of this step, what does it mean, and there are many more in a processing that we will be covering in OpenCV in more detail along with the code. let's move with the image enhancement. Enhancement means only by word only we can know that making a picture more nicer. Like here we can see the input was little means discolor and more noise were there, where the output is really fair with bright colors. So means basically it is giving a touch up to the picture to make it more better. So it can be done by either darkening it or brightening it, adjusting the color, reducing some noise happening. You all must be aware of some of the noise or heard, like pepper noise, Gaussian noise, white dot noise. So I will be discussing detail about these noise also in coming videos. The other thing, image reconstruction. Remember, in children, we have a puzzles like small shapes are there. We need to assemble all these and convert it into a big frame. So, image reconstruction is also the same. Like we have a many torn photographs, and our aim is to glue them back to restore the original images. So, it can be done via these steps. First, we collect the pieces, puzzle pieces, and gather the information from various sources like photographs, sensor, etc. Once we have all the pieces, we convert in image reconstruction. We mainly match up different parts of the image to create a seamless whole. This might involve that we adjust the size or rotate or position of the pieces to make them fit perfectly. Sometimes there is a situation that a piece is missing in the puzzle. So in image reconstruction, also there may be some parts of the picture that are incomplete or absurd. So whereas various algorithms are used to fill the gaps by educating themselves around a puzzle of nearby and filling that place. So all these will be covered in coming chapters, where we will be going through each and every code and get how it is done, so that we can in our real world we can implement that in our life projects. Then come the other thing, that is the image transformation. So image transformation is just a magic that change the appearance and properties. As you can see that we have changed the butterfly, black butterfly to white butterfly, or we can also make new patterns on white butterfly or erase some patterns. So it is basically a kind of giving a kind of touch up only, but in a form that it transform the property, some of the property of the image. By this we have came to the end of our first this video. So basically I would like to end it with the difference between the computer vision and image processing. So when we talk about computer vision, it is understanding and interpreting image to make decision, and in image processing it is somehow manipulating or enhancing the photo and extracting the information. It is not the interpreting and understanding games in image processing. And as we all earlier told, that high level like detection, recognition, and 3D tasks come into computer vision, whereas a low level like compression, adjustment, these are come. And in computer vision, we mainly make the use of deep learning framework like CNN, YOLO, SST, UNet, Deep Lab. These are I will be discussing in further DNN session of our video playlist. And for image processing, it is mathematical and algorithm techniques we use simply by doing the calculation in pixels of the image. We try to make these changes, and it is possible via this only. So for simple image processing techniques, we don't get into the computer vision, because computer vision requires a lot of computational units, and means it is a little costly as compared to image processing. at last, I want all of you to go through the roadmap which I will be carrying in my playlist Computer Vision. First is the introduction to Computer Vision that I have carried full from tomorrow, or means from next lecture. I will be going through the different platforms such as TensorFlow, PyTorch, Cafe, ONNX. I will giving a basic understanding of these, and then we will pick one of the a model which we all want. Basically, PyTorch is where means I am going through PyTorch. If you all want TensorFlow or Cafe, I will also share the link for that. Means I have implemented that before in TensorFlow and Cafe, so I will share that. And after that, we will be going through OpenCV. It is a kind of means library that mainly deals with the and this image processing and everything we can carry out by using a simple function. And we will be comparing earlier methods also, that before OpenCV what we used to do and how OpenCV has changed and what function of OpenCV we can use to carry out that technique like these. And then we will be moving to the deep neural networks, that is the various framework of the deep learning to get each of the means task which I have defined earlier in computer vision, like object detection, image classification. And then I will go through a live project that will make sense and mainly strengthen your CV. And then we will go through deployment of the live projects. Like I will be going through 4 to 5 live projects, and deployment I will show of 1 to 2, because the deployments are mainly means similar only. So I will show you of 1 to 2, and then I will go through the ML ops. It is also an important thing that is emerging, because we also want to notice and look after our model whether it is performing well as before or it has deteriorated. So at last I will go through some ML ops techniques and how it is done pipeline. And then I it will miss our playlist will end. Hope you all will continue to watch the coming videos, so also I can also get a motivation to make more and more videos. Yeah, thank you.